So welcome to R2 floats equal. Why am I calling the video that? Let's dive in and find out. Okay, so let's handle these aiming and locked states now. So in order to differentiate between aiming and lock, we're going to need to know if the barrel is moving. So I'll write the surrounding code and then I'm going to give you a challenge to write the isBarrelMoving method. So we're going to say else if isBarrelMoving, wishing that we had that method, is called wishful coding. Then, if we had a way of detecting that the barrel was moving, we would set the firing state to, and then I'm going to copy the beginning all right because there's a lot of noise there. E-firing state aiming. Then we move down one. Finally, else, and the order does matter here if you think about it. Else, we're just going to be in the firing state of locked. So we're saying that reloading, the fact that it has been, oh look, there's an error here, the platform time minus the last fire time needs to be less than the reload time in seconds in order for us to be in a state of reloading. That overrides everything else. If that's not the case, then we ask the question, is the barrel moving? If the barrel's moving, well, then we're in an aiming state. We're free to fire, but we're in an aiming state. Otherwise, we're in the lock state. So we've done that in theory, handled the aiming and lock states. What we need is a isBarrelMoving method. So I'm going to go ahead and ask you to do that. Write bool isBarrelMoving. Compare the barrel's current forward vector with the aim direction that we're using within the aimat method. Now, when you try and compare two f vectors, you're actually remembering that f vectors are a struct containing floats. So what you're really trying to do is compare floating point values. Now, we can ask the question whether floating point values are larger or smaller than each other, but never, ever, 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 ever ask whether two floats are equal. It just doesn't make any sense to even ask the question. It's like saying, are two people the same height? You can't even ask the question without specifying a tolerance within which you are asking the question. Are two people who are about 180 centimeters the same height? Don't know. Depends whether you care about the millimeters, depends whether you care about the microns, etc. So when you compare two floats, you must do it in a way that says they are equal within and then insert a tolerance. And that's exactly what this static method called equals that's available on every f vector does for us. We'll take one f vector, like the barrel's current forward, we'll say dot equals, and then inside the dot equals there are two parameters. One is the other vector, and then the other is the tolerance. And I'm going to use 0.01, just for a small number. Anyway, test that it works by seeing if it changes the color of the crosshair. And I've got a hint coming up next, so if you're ready for the challenge without a hint, go ahead, pause the video now. If you want a tiny bit more information, here it comes. I suggest that you promote the aim direction local variable inside the aimat method up to a member variable for ease. Okay, go ahead, pause the video and have a crack at that now. Okay, welcome back. Let's make this isBarrelMoving thingy happen. I'm going to do it, I think, under the initialize. In fact, I'm going to move initialize above tick component, OCD, that's what I call it. Okay, so we do the begin play, then we do our kind of manual initialize, then ticking happens, and then we ask questions like void, spelt utank, aiming component. I should have copied that, shouldn't I? And then isBarrelMoving, comme ça. Okay. Great. I'm going to go ahead and declare that right away. Where do we put it? Doesn't really matter. I think it makes sense somewhere like below the move barrel towards. It's a boolean. If I made it void in the tank aiming component, I was wrong. I'll fix that in a second. Its bool is barrel moving, and it needs no parameters. Self-explanatory what it does, but the return type is bool. Okay, so how are we going to do this? The first thing is that we should never be calling this method when there is no barrel. So we need to protect against the idea of there being no barrel when we call this. Now, if there was no barrel, would we want to... I want to talk a little bit more about the ensure statement. We only use ensure for things that we never, ever, ever expect to happen in our production game. If this stuff is likely to happen in the production game, then it's a failure condition you need to handle. So is it possible that our code would call isBarrelMoving when there's no barrel? It really shouldn't. So I'm going to use an ensure here. So if not ensure barrel, then we're going to return. Now careful, return what? True or false? You can't just say return out of a method that returns a boolean. Now let's think about what the most sensible failure case is. If I ask the question of a method, is the barrel moving, and there is no barrel pointer, if we've got a choice between true and false, assuming we're not returning a richer error like an enum, then I'm going to give it false in this case, because how can the barrel be moving if the barrel pointer is not set? Okay, you could argue if it was any more fringe than this, I would suggest you don't return a ball, but you return an enum that gives a meaningful piece of information back. So your options would be, yes, it's moving, no, it's not moving, or don't ask me, I can't even look through the barrel pointer right now, mate, which might be a slightly longer enum state than we need, but you get the idea. So with that protection in place, let's dive in. Auto, I'm going to say barrel forward, very thin variable here, it's just for self-documentation. And we're going to look through the barrel pointer, which we've protected, get forward vector, which I'm pretty sure we've used before. Okay, so what are we going to return from this method? We're pretty much ready to return. We're ready to return, I'll pseudocode it. We're going to return the Boolean that is not the vectors are equal. So if the forward direction and the aim direction, which is where? Let's go find it, aim direction here. If they're equal, then the barrel is not moving. If they're not equal, the barrel is moving. So it's the inversion of whether they're equal. So I'm going to say if barrel forward dot equals, now you can find out about this method, by the way, this dot equals, it's here. I've put it in the resources of the lecture for you, and it tells you what it does. It does a comparison with a tolerance, as I said. To what? Well, to this aim direction. We need to promote that in a second. I'm going to give it 0.01 for no particular reason apart from it's a small number, which means that they look equal enough to be good enough for me. The only thing is that aim direction is out of scope now, of course. It's not inside this method. And it no longer needs to be just a local variable inside this AIMAP method. We can take the auto off, which turns it from a initialization and declaration simultaneously into a nothing, because it doesn't know anything about aim direction. And that's simple. We move aim direction into a f vector local member of the class ComSat. Okay, so we have an aim direction to compare towards now. When Visual Studio catches up, all these red squigglies will go away and we should be in good condition. So that's basically the crux of is barrel moving the way I'm doing it. Let's go ahead and compile and see what we get out of this now. By the way, make sure you switched your chevron round here in the question in tick component. Is the time since the last fire time less than the reload time in seconds, not greater than in this case, okay? Otherwise, you won't be in the reloading state. So that's an important note there. Also, if you don't like F platform time, and you probably shouldn't like F platform time, I was showing it to you as an alternative, you can use get world, get time seconds. That will work just as well, if not better. So I'm going to leave it until we actually need to make a change back to get world, get time seconds, but just a note for you. Okay, let's play the game, see what happens. So it's red and I can't fire, that's good. After 3 seconds, what happens? Well, we get a big glitch, and then, okay, nothing, it's not working. So what's wrong? Let's have a look at the stack trace. Ooh, lots of stuff's going wrong here. So we've got something moaning about the color and opacity, which is a blueprint variable that we have, if you remember, on the UI. So let's go and look at that. While we've got these errors, let's deal with them one at a time. So on the UI here, we read under the player UI a blueprint variable in the graph, which is here, which is the BP aiming component reference. Let's turn that into a string and then print it. Oh no, we don't need to, because we know that that is being set, because it is actually setting a color. So let's not necessarily do that, but note the following. The BP aiming component reference blueprint variable here is currently private. Let's make that public by clicking the little I there, because it's being set from one blueprint and read from another. So make that public and compile. That should get rid of this error about trying to access that blueprint variable. Now, we've got a projectile blueprint inshore failure on the tank aiming component line, what line? Love these line numbers, 100. So on line 100, we are not having a projectile blueprint available. That is probably because the AI tank is firing too early. So have we prevented it from firing at the beginning? Yes, we have. So it's not that. Let's have a look. Let's recompile and have a look and see how it's behaving now. Play. The AI tanks, when are they firing? They're firing after, yep, and I can fire after 3 seconds. Let's just see if my crosshair goes amber. Yeah, and then green. Actually, it's working. So, because I've had some ensure problems, and because we know that the ensures only work once per compilation cycle or once per opening of the editor, I'm actually going to close the editor and then reopen it just to ensure that we don't have any problems after that, because I don't want to ignore these ensures. It's easy to look past them when you're trying to get something done and to not deal with them. So now I'm reopened to make sure. Now I'm waiting a few seconds. See, it goes green when the barrel's moving, it's amber, and when I fire it goes red for 3 seconds. That looks good, and I'm getting no errors in the console here, so that is a lot better. Let me show you the code that I've added in source control briefly, and remember you can always look this up by going to the GitHub repository for the course, and we're good to go. So what has happened in this video? It's wrong. We haven't moved the initialize. That's just source control getting confused about the changes. We have switched the chevron round, the comparison round in this F platform time. We've written this code here to do with the barrel moving states. And then, of course, we've written the entire is barrel moving method, which was these 3 lines there. The header component change, the header file changes are just the required things to make all that work. So great, it's good news. We actually have aiming working, which is quite satisfying. And it's much nicer now that you know when you can and can't fire. I'm just going to get my controller out and have a play and have a quick think about what's the least fun thing about this. And I think the least fun thing now is this slightly ridiculous moving metrics, which is where the tank's physics is a bit knackered because it skids sideways so much that I can't really control it. That's actually starting to become annoying now. So is the fact they're bouncing off the ground like that. Both of those things are somewhat annoying. So that's what we're going to fix next, but at least we have a crosshair that gives us some affordance, as they call it, as to when we can and can't fire and why we can or can't fire. So I look forward to seeing you in the next video.